DNA double helix. From first year. Each nucleotide has a sugar, a nitrogen base, a phosphate. What was bond between sugar and nitrogen base, Nana? Glycosidic bond. Between sugar and phosphate, ester bond. Between two nucleotides, diester bond. Between nitrogen bases of opposite strands, hydrogen bonds. Kada? So, anyhow, aerobic respiration. We have done glycolysis part already. Then link step also. Tell me, Nana, what is called link compound between glycolysis Krebs cycle? What was called link compound, Nana, between glycolysis Krebs cycle? Link step between glycolysis Krebs cycle is oxidative decarboxylation of pyruvic acid to acetyl-CoA. Kada? And pyruvic acid was undergoing actually in the same step, three things it was undergoing. Enanani, decarboxylation, Kadanana, using, if it is two molecules of pyruvic acid, two carbons removed as carbon dioxide, then dehydrogenation, wherein two molecules of NAD plus reduced into NADH plus H plus. So two more redox equivalents released out from the substrate. Already work from glycolysis we have seen. Tadanana. Then condensation with coenzyme A. So what is it you got here? Tell me.
Acetyl-CoA.
Two molecules of acetyl-CoA. Each is two carbons, so four carbons. Out of 6 carbons. Gone. So this is carried out by a cluster of 3 enzymes, Nana. One causing decarboxylation, decarboxylase. Another causing dehydrogenation, dehydrogenase. This is second oxidation of aerobic respiration, we can also call it. Removing hydrogens from pyruvic acid added to NAD to form base. Then condensation with coenzyme A by trans-acetylase. So cluster of 3 enzymes. What was that called, Nana? Dehydrogenase complex. Hello? This dehydrogenase complex, just to have an idea, I'm telling you, Nana, is a cluster of 3 enzymes. That is 1 decarboxylase, 2 dehydrogenase, 3 trans-acetylase. So these 3 together is called dehydrogenase complex. It is not, of course, a reversible reaction. When I say reversible reactions, isn't it, Nana? From glucose up till now to acetyl coenzyme A. From one glucose, we got 2 molecules of acetyl coenzyme A. This is also important and a possible for question for this weekend itself. From glucose to 2 molecules of acetyl CoA, that is in glycolysis and link step. All biochemical reactions or reversible except two reactions, Nana. One, reaction 3 of glycolysis, that is phosphorylation 2 of glycolysis. Be careful, Nana. Phosphorylation 2 of glycolysis. Can you tell me what was that reaction, Nana? Fructose 6 phosphate 2. Fructose 1,6 bisphosphate. This is not reversible, Nana, irreversible. And also this one, that is pyruvic acid to acetyl-CoA. Important, Nana, this point. Up till now, except these two reactions, all are reversible. So these two reactions, however, are irreversible, not reversible. Very important to remember. Phosphorylation 2 of glycolysis. And conversion of pyruvic acid to acetyl-CoA. That is link step, you also know. Which are not reversible, remaining all from glucose, especially from glucose to pyruvic acid. That is glycolysis reactions especially. All are reversible, but exception is this, possible for this weekend itself, a question on that. And the second thing to remember is dehydrogenase complex. It's a cluster of 3 enzymes. How many were cofactors used here, Nana? 6 cofactors, isn't it? 2 already shown here. NAD and coenzyme. Apart from that, what else were they? Remember, Nana? Tell me better. Mg plus 2. FAD. Inka? Thymine pyrophosphate. Also, lipoic acid. 1, 2, 3, 4, 5, 6 cofactors of the enzyme dehydrogenase complex. This, of course, we have seen already. Even yesterday also we discussed. Tell me, Nana, this link step was occurring in which part of the cell? Can anyone please?
Cytoplasm, sir.
No, better. Glycolysis was in the cytosol part of cytoplasm.
Matrix of mitochondria.
Ah, that's it. In the matrix of mitochondrion. So next. Okay to rub off this part?
So 1 minute.
Okay. ఒక్క నిమిషం నాన్న. ఓకేనా? సారీ. Right, beta? Done, Nana?
Yes.
Yes, sir.
Okay. So now, what is the third step of aerobic respiration? Step 3. TCA cycle. What does it mean, Nana? Tricarboxylic acid cycle. Also called Krebs cycle. Also called citric acid cycle. Also called organic acid cycle. So many names now. How are these names? Let us see first. Reason is many intermediates okay, Nana?
Yes.
All right. Many intermediates in this pathway are organic acids like malic acid, oxaloacetic acid, succinic acid, alpha-ketoglutarate acid, citric acid. That's why the name organic acid cycle. Why the citric acid cycle? Because the first stable compound in this pathway is citric acid. Tell me now why it is called Krebs cycle? It is named after the discoverer. Who discovered this? That is Sir Hans Krebs. So named after who it is called Krebs cycle. Actually, Krebs The cost of reaction should be some they are interpreting as crepes. Then guess and tell me now, why should it be called a tricarboxylic acid cycle?
So your camera is off.
Oh, sorry. Yes, and tell me now, why it is called tricarboxylic acid cycle? Because many intermediates have pre-carboxyl groups in them. So many intermediates are tricarboxylic acids with three carboxyl groups. Example, citric acid itself, Nana. See, so many names for citric acid cycle. This tricarboxylic acid cycle is, as per NCERT, is in a very briefly given. So citric. Here also, an altogether of 10 biochemical reactions. Now, glycolysis was also 10 biochemical reactions you have seen. Like in glycolysis, here also, enzymes names won't be a problem to you, Nana, because there will be 4 oxidations in this. In all the cases, enzyme is dehydrogenase, finish. Like 4 were by kinases in glycolysis. 4 are oxidations in this by dehydrogenase. And 1 will be kinase reaction. So 5 gone. And remaining 2 are isomerases. So 7 gone. Remaining 3 will not be a problem to you in remembering. So how are the 10 biochemical reactions is to be seen. And this occurs in which part of the cell, Nana? In again mitochondrial matrix. As the enzymes required for it are occurring there. Link step also occurred in mitochondrial matrix only, but glycolysis was in cytosol part within the cytoplasm. Fermentation also was cytosol part within the cytoplasm. And it involves citric acid cycle involves 2 decarboxylations, 4 oxidations, In fact, out of the four, two will be associated with decarboxylation. Means you can as well call them oxidative decarboxylation. Just I'll first draw the cycle and then elaborate it more. And one substrate level phosphorylation also. SLP, which will be giving us ATP directly. Like there were two substrate level phosphorylations in glycolysis. Yes, we draw the outlines and then go into the details. Done, Anna? Shall I rub up this part? Up to this, okay, I think?
Yes, sir.
Because that diagram based question is possible. Acetyl CoA, which is a two carbon compound. We have two acetyl CoAs, so it will undergo two times now for two molecules of acetyl CoA. So for each glucose, there will be 2 turns of TCA cycle. That is another important thing. Better you write now. There are, before we draw the cycle only you write now. There are 2 turns of TCA cycle occurring for one glucose. This is also equally important. So each molecule of acetyl CoA, because we have two acetyl CoA molecules from one glucose, because during glycolysis, glucose gave us 2 pyruvic acids, and in link step, 2 pyruvic acids converted into 2 acetyl CoAs. Now, each will undergo a turn of TCA cycle. So this acetyl CoA first undergoes condensation. Very briefly he gave in the textbook, but we elaborate. With oxaloacetic acid. Which is a 4 carbon compound. This time, water molecule also used for each molecule. You get citric acid, 6 carbon compound. This will undergo isomerization into cis-aconitic acid, then into isocitric acid. isomerization into. Within this actually two steps missing. Isocitric acid. Which is also 6 carbon. So no carbons removed. Then we'll undergo two successive oxidative decarboxylation. Through oxalosuccinic acid, alpha ketoglutaric acid. This time, a carbon removed as CO2, then a molecule of NAD reduced into NADH plus H plus. And this to another part. Okay. This actually should be called oxidative decarboxylation because decarboxylation, oxidation both. Decarboxylation and oxidation. This will also undergo the same thing using one more carbon. This is 5 carbon, using a carbon, 6 carbon became 5 carbon. Uses another carbon during this time also. An NAD plus reduced into NADH plus H plus. So here 2 redox equivalents removed and added to NAD. Here also 2 removed and added to NAD. This can as well be called decarboxylation and oxidation. So successive decarboxylation. You get succinyl coenzyme A. So this is also condensing with coenzyme A. Same like in link step now. Then this will undergo substrate level phosphorylation. During this time, we get 1 GTP by GDP plus inorganic phosphate. You get succinic acid. Here onwards, all are 4 carbon organic acids. This is substrate level phosphorylation, oxidation and decarboxylation, oxidation and decarboxylation, isomerization, major things. This will undergo one more oxidation to form malic acid. This is just oxidation. This will undergo another oxidation. So total how many oxidations you noticed? 4. This time also 1 NAD plus reduced into NADH plus H plus. So oxidation number 1, number 2, number 3, and number 4. So 4 oxidations you notice. One was in glycolysis, one was in link step 4 or during TCA cycle. So regenerating oxalic acid so that it can again combine with another acetyl next time. This is one turn of TCA cycle. So each turn of TCA cycle for one acetyl CoA yields two carbon dioxide molecules, 3 NADH plus H plus, 1 FADH2, then 1 GTP by Sn. Therefore, it is for one glucose, 2 turns of C side, TCA side. Therefore, for one glucose, because we have 2 acetyl CoA molecules for one glucose from 2 pyruvic acid. Therefore, for one glucose, the 2 turns of TCA cycle yields, and altogether of double to that. So 4 molecules of CO2, 6 molecules of NADH plus H plus, 2 molecules of FADH2, 2 molecules of GTP, which are on par with ATP. This is purely as per NCERT sequence. If you start from pyruvic acid, before that it was pyruvic acid, no. If it is for one glucose, link step, 2 molecules there, so twice you take it as this also twice. Done this none, all of you?
So 1 minute.
Okay. ఇది కనిపిస్తుందా అన్న బాటమ్ లో 4 CO2 6 NADH plus H plus 2 FADH2 2 GTP double to these nana simple. From link step, we have two more NADH and two more carbon dioxides. It should be taken as for two pyruvic acids.
Done, sir.
Okay. So therefore, two molecules of pyruvic acid from one glucose that was found in cytosol part enter mitochondrion and yield eight NADH plus H plus. 6 molecules of CO2. Out of them, 2 in link step, 4 in PCSLP. 2 in link step. 4 in link step, better 4 in PCSIP. Then 8 NADH plus H plus. Out of them, 2 in link step, 6 in PCSIP. Also, 2 FADH2, all from TCA cycle. Also, 2 GTPs from TCA cycle. So literally, hydrogens removed from pyruvic acid are added to whom, Nana? Or added to NADH and FADH, FAD, sorry, NAD and FAD to form NADH plus H plus and FADH2 respectively. The hydrogens from pyruvic acid are now with NADH and FADH. And from them, by electron transport system, their electrons will be used up in ETS. So the electrons of those hydrogens are used in electron transport system, the so-called oxidative phosphorylation. Otherwise called electron transport system. To form ATPs and water. Who's that? So same TCA cycle. Now we are going in detail now, because from this NCERT textbook it is the skeletal points, which is not easy to understand. Just outlines of TCA cycle along with link steps summary is given here in fact. So details of TCA cycle we are going now. That's important. If it is 2 molecules of pyruvic acid is this. For 1 pyruvic acid, I will write half of them. 3 CO2, 4 NADH, 1 FADH2, 1 GTP, which is on par with ATP. How it is on par with ATP, we will see now. If you have done this, then we'll go for details of TCA cycle. So we take it as 2 acetyl-CoA molecules. What is the yield from TCA cycle going to be? We'll see now. Shall I rub off this part now? Okay. Tell me, Nana, if you have done it. So TCA cycle in detail. At least half page it requires, Nana. Plan it accordingly. Krebs cycle in detail. For two molecules I'm taking. For one glucose, we have two molecules of acetyl-CoA, acetyl coenzyme A. Two molecules, each with two carbons, so 4 carbons. Condenses with two molecules of oxaloacetic acid. Of course, in presence of two water molecules also. You get two molecules of citric acid. Each is 6 carbon. Oxaloacetic acid is 4 carbon. So 8 carbons of OAA, 4 of acetyl-CoA, so 12 are in 2 molecules of citric acid, which is 6 carbon. That is first stable compound. Enzyme. So reaction 1. Condensation. Name also important. Better write in a box. Enzyme is citrate synthetase. Write in a wavy circle. Citrate synthetase. Reaction 1, condensation. 2 water molecules used here, remember. Then second reaction is isomerization, which in fact is next also together with isomerization, we call it as hydration. Sorry, dehydration. What is dehydration, Anna? Addition or removal of hydrogen or water?
Water, sir.
Removal of water. Two molecules, no? So 2 molecules of water remove. You get here 2 molecules of cis-aconitic acid. Each is still 6 carbon. Followed by reaction 3, hydration. Removed water is added. So that's why 2 together also taken as isomerization. Water removed, water added. From one place added, another place, one place removed, another place added. So removed water is being added. You get 2 molecules of isocitric acid. Each is still 6 carbon. Some interpret Second and third as isomerization, because second and third are by same enzyme, Nana. Enzyme is cis-aconitase. Same enzyme here and there also. Here, this enzyme, even in this reaction also, same enzyme. Sorry. Second, third reaction, same enzyme, Nana. So, it can 2 and 3 together be called isomerization also. First we removed water, then we added water. At the end, if you see, nothing is net addition, nothing is net removal. Okay, what is time now? Yeah, we'll stop here, Nana. We continue tomorrow, not a problem. Okay, shall we stop
Okay,
here?
sir.
Yes.
sir.
Yes, sir.
Thank you, sir. Bye, sir.
Bye, Nana.
Bye, sir. Thank you, sir.
Good morning, sir.
Good morning, Nana. Junior started 1 minute, beta. I'll just close it and come back. Done all of you second year? Shall I close it, Nana?
Yes, sir. Thank you, sir.
Okay, Nana, bye.